Okay, so they have actually calculated according to the formula, you know, rate equals to changes in concentration, okay, divided by time. So they actually use the concentration divided by time, and then they have all these data. Okay, you can see all this data. And what I want to know based on this data, Charlton, is concentration of cyclopropane. If you just look at this equation, okay, it is a forward reaction. So what do you expect about the concentration of cyclopropane? Are they going to actually go down or increase?
Go down.
Go down, yeah. So concentration itself, it's supposed to go down because they are reacting, okay. But this is going to be concentration, yeah, not rate, yeah. Before this one, hold on, okay. I went too in front already. Okay, here, okay, it's just concentration, and you know that the concentration will go down. So they actually, you can see the concentration is going down. And I know propene is being formed, okay, from zero, from nothing, okay, then it's going to actually increase. You can see that, okay, propene is being formed, okay. It means concentration is increasing, concentration is decreasing over here. That is very important, yeah. So if I put it in form of graph, okay, if I put it in form of graph, okay, I can see what is going to be changing, yeah, changing according to time. So they actually drew one graph, okay, they actually draw the graph, okay, but they refer to propene. So when they refer to propene, let's actually look at propene. Okay, if I bring this over there, just okay, I bring it like this. Now, if you look at this data, okay, so they want to actually look at propene, okay, propene. So you have a look at this data what for propene, yeah, from zero, okay, from zero, it means at time zero is going to be zero. So time zero is going to be zero. And then further, okay, if you go further at 5, okay, the value is going to be 0.27. So 0.27, they have plotted the graph, okay, 0.5 for 10, 0.5 for 10. Okay, they have plotted the graph. Now, when they plot the graph, okay, what did they see? Of course, they saw the increase in concentration of propene. Why? Because propene is the product. So product is being formed. Okay, so it went up. Okay, you can see the graph is going up, but it's like going to become like slightly closer, like where it's going to become like constant. Okay, it's going to be closer to constant. Why? Because I think later part it will become constant because no more reactant. Okay, if there is no more reactant, it means following the time, okay, no more not to say no more additional propene that is going to be formed, so it will become constant. It means we are going to expect the graph to actually go like this, then slowly it will become like this. Okay, that is our expectation. Yeah, because why? The limiting factor is the reactant. So now what they actually did, they actually draw another graph. What is the graph that they draw? Okay, they actually took from 0 to 5. You see 0 to 5, this one. From here to here, okay, it means they took this part of the graph, okay, what they actually did, they enlarge, okay, they enlarge the graph. Okay, but you can see roughly, okay, this graph is going to be something like a straight line here. Okay, something like a straight line here. They enlarged the graph. Okay, when they enlarge the graph, you will notice that, okay, this is going to be the thing that earlier, based on the earlier graph. Okay, this is going to be based on the earlier graph. Okay, and I found out that it's going to be giving you this graph. But okay, if you see A, they say A is the whole curve. okay, previously, like if you keep on going, then it will actually curve. Yeah. So here they say there is going to be A shows the average rate over 5 minutes. Okay, fine. But line B shows the actual initial rate at the start of the curve. Okay. So you see here, line B at the start of the curve, they actually start to make another line, which is going to be some sort of a tangent. Okay, I know, I hope you know what is tangent here, your maths. Okay, if you have something like this, okay, if they touch in one place and then touch at that one point only, yeah, so that is going to be known as tangent. Okay, so what they did was, okay, they actually draw another line showing that this is going to be the initial rate, the tangent. Okay, how did they actually draw or come up with this line? Okay, maybe normally when I cannot show, but in this case I think I can show you very clearly. Okay, maybe I'll put use this. You see, when I have this line, when it's touching over this line, when I just try to bring it over here, you see it touches most of the lines, the red line. So I'll just keep on bringing it. Okay, and you can see towards the moment that I can only go through point zero, it means doesn't actually overlap with the red line. Okay, that's going to be my tangent. So I slowly go up, still there's overlap towards the bottom, still I go up, still I go up. Now this is going to be something that just touches one single point over there. So this is going to be the tangent. I hope you understand this. Okay, so if you still don't understand, I can use another color. Okay, I'll show you. Okay, I'll erase this again. Okay, you can see I want to just touch at this point. Okay, this point 0. So I bring it out. So draw a straight line. Okay, now I want to find the tangent, so I need to move so that it just touch one point. So I adjust and adjust. Okay, then I came up to this. Okay, that is going to be the tangent. Okay, take note. Okay, because normally when I want to show it using the graph, it's very difficult, but I think using this I can actually show you. Okay, this is going to be how the tangent was found. Yeah, so some of you will think that, oh, touch one point, even if I actually draw like this also touch one point. No, because they will intercept, cannot intercept. Okay, again, you see, when you draw a tangent, you want to touch and go, you cannot actually touch and intercept. Okay, so this is one of it, one of the way, okay, that I can actually explain about this tangent. Yeah, so here, okay, they have done, okay, an actual initial rate, okay, drawing a tangent. Yeah, they draw a tangent. Okay, now why they mention about rate? Okay, the rate is found from concentration divided by time. Now, if you find the gradient, okay, the gradient of line A and line B, you can find the gradient. Okay, if you find the gradient, how to find the gradient is going to be this y, okay, divided by this x. Okay, that's going to be the gradient. And then I can actually find the gradient of this as well. This is going to be y, and then divide by the x. Okay, so it means that the gradient, both of the gradient are different. Okay, both of the gradient are different. So initial rate, when they say initial rate must follow the tangent. So that's why it's not going to be the actual value that you get from the graph. You must draw a tangent. So initial rate is different. Yeah, slightly different. So here, okay, they have actually done another graph. Okay, this graph, okay, is going to be for propane. But how about if I draw a graph related to cyclopropane? So I'll bring it over here. Okay, if I want to actually draw cyclopropane graph, okay, and I know the cyclopropane is reactant, they are going to decrease. So you see that this is going to be 1.5. Okay, so 1.5. Okay, hold on. 1.5, so 1.5. And then 1.23, so you have 1.23 over here, and so on. They draw a curve. Okay, this is going to be the curve that you get for this. And then, okay, again, similar to just now, let's say not only at 0.0, I can actually measure at any time interval. Let's say I want to actually find out what is going to be the rate at specific time, which is going to be at time equals to 10 minutes. How to do that? Okay, you just need to actually draw a tangent passing through this point. Okay, so this one you can see from here, they actually took I'll just draw like this. Okay, and then I try to move. Okay, you can see they pass through, then they manage to touch at one point. Okay, so they touch at that one point, and if you can measure the gradient, you can measure the gradient by taking by looking at this y and then divided by this x. Okay, the gradient will tell us, okay, because this is mole per dm cube, this is time, which is minutes. So it's going to be, if you find gradient, it's going to be y divided by x, which is going to be mole per dm cube, divided by time, which is per minute. So it's going to be, you are going to get mole dm negative 3 per minute, which is actually the same as concentration divided by time. Okay, so that is going to be the way that they measure the gradient, okay, from the graph. So here they actually measure, okay, they took the gradient and so on. They actually got something like this. Okay, they have changed this into seconds because for the formula, change in concentration divided by time, the time that they meant is going to be seconds. Okay, so they can actually calculate this. Okay, we can calculate using graph. So everything that we actually do is actually related to the graph. Okay, they actually did everything based on graph. Yeah, they record everything through the graph. So for example, okay, if you look at this, why this is so complicated? Actually, it's not complicated. It's the same graph. Okay, it's the same graph. What they have done was, okay, they have done at different time interval. Okay, what time interval? You can see that they have done okay, they have done for this first, okay, the t equals to 0. This is going to be for t equals to 0, the gradient. And then you have the rate at or they mention it as the rate at concentration of 1.5. Okay, if you want to actually refer to that. So they have done for this, they have done for this line is for, okay, if I try to make sense, this is for 1, okay, at this, I think at 10 minutes. And then they have also done the same thing for 0.5. It means if I bring 0.5 is somewhere here at this point at 25 minutes. They also have done that. So what they did was they calculated the gradient. Okay, they calculated the gradient. So if I actually try to calculate the gradient of this, okay, let's say I don't follow what they have done, okay, but let's say I just want to actually figure out, okay, something similar to what they have done. If you follow, like for example, if I just simply follow here, okay, if this is the tangent, I will have something like this triangle. Okay, I want you to really see this properly. There is a triangle over here. Let's say I select any other point, maybe this point, okay, and I try to draw something like a tangent. Okay, this is my tangent, for example. I try to make it here. Okay, then I draw another triangle, for example. It's not so accurate, okay, but I just want to show you something. This is triangle number 1. This is triangle number 2. Okay, and I draw another triangle somewhere here. So if I want to draw the tangent, okay, maybe it's not so accurate. Okay, something like this. Okay, I'm going to actually draw a triangle here. Yeah, I think we'll do. Number 3. What can you say about the gradient, Lavi? based on my three triangles?
The gradient is
Is it getting steeper or less steep?
it's getting why it suddenly become lesser then become bigger?
No, actually, when we see gradient, right? Okay, I think you need to understand the concept of gradient. This, okay, if you go up the hill, then you keep on going up the hill. Let me. Okay, this is going to be, let's say you're cycling or something. Okay, this one, you are trying to go up the hill. Yeah. Then after that, okay, let's say the hill is more steep. How do we say hill more steep? Yeah, this is going to be steeper hill, right? You try to go up, it's more difficult. Okay, if it is more way more steeper, then it will keep on going up. Okay, so how do we actually measure gradient? Gradient is this one divided by this, right? So you can see that this one is actually keep on increasing. Okay, if it is increasing the gradient, it means gradient is increasing. How? Because the angle is getting more. Okay, so here, if yeah, in this case, are we referring to grade is getting less steep, or is it going to become steeper going down because it's proceeding this way, right?
Because gradient is decreasing, so it's
less steeper, right? So it's getting less steeper. So if it is going to be less steeper, means the rate of reaction, okay, the rate of reaction is decreasing. Okay, you can see here, okay, the rate. If you look at the rate over here, the number, you just look at the number. Okay, the number is going to become -3 to -4. Okay, if -4, then you see the number here 6.637 to become 3.30. Yeah, so it means that, okay, the rate, okay, is decreasing as the reaction proceeds. Okay, now what they actually done, okay, what they have done, they took that value of that rate. Okay, they took that value of that rate. They went and actually divided that with the concentration of cyclopropane. It means this is the rate, they divide with this. This is the rate, they divide with this. This is the rate, they divide with this. Okay. What they have done based on this, they found out this value is constant. They found out that this value is constant. Now, what is so big deal about this? This one, I tell you what is the big deal. If you are good in maths, you will understand what's the meaning. Okay, basically, if I have rate divided by concentration over here, it means that if I have your rate is y-axis. If I have rate and I have another graph over here, concentration of cyclopropane. Okay, concentration of cyclopropane. If the gradient is the same, okay, if the gradient is the same, it means the graph, what kind of graph will we get, Justin?
Straight line.
Yes, it's a straight line. This is what they mean. It means at this point, okay, if you have at this concentration, yeah, the rate is still the same, which is this. At this concentration, the rate is still going to be the same. Okay, at this concentration is still going to be the same. So it's a straight line graph. So they have found out there is some sort of a relationship. Okay, they found out there is some sort of relationship when it comes to rate over concentration graph. And they have found out there is also some sort of relationship when it comes to other graph, which is going to be concentration against time graph. Okay, so earlier we actually did the concentration against time. So the thing is, based on these graphical methods here, right, they actually found out it is very important, okay, when it comes to this rate of reaction. it is very important if I need to actually find out about my concentration versus time graph. And another important thing is they have found out that the rate versus concentration graph also going to be important. I hope you understand this. Okay, based on this, okay, they actually found out that these two graphs are very, very important. Okay, they found out that these two graphs are going to actually tell us something. Yeah, it's going to be telling us something. We can predict certain reaction, how it proceeds. Okay, so these two graphs, okay, we will actually, I don't think so we will finish everything related to this today. Yeah, so we will definitely continue on Monday. Yeah. So do remember our discussion on Monday, okay, the one that I told that Mr. Rufus, Mr. Sammy will be coming. All this will be actually included on the discussion on Monday. Okay, we will actually discuss on this. Okay, the graphs. Okay, so now what is going to happen over here is, okay, if you put, like for example, another example, just now they actually put for cyclopropane. So here they have different. Okay, they say that, okay, rate, and then I put cyclopropane. Just now I showed, okay, this is going to give you a straight line graph. So you see, you can actually put a straight line graph, okay, using that. So they say that, okay, from here, what I can see that when my concentration is doubled, it means when 0.5 become 1, what happens to my rate? My rate was, okay, somewhere here, now become somewhere here. I found out, okay, the rate is going to become double. Okay, this one maybe 3 point something. Okay, 0.3 something. So what happened is it became 0.6 something here. Okay, maybe just put 0.33. So it become 0.66. So you can see that, okay, when the concentration is being doubled, the rate is being doubled. If the concentration falls to 1/3, okay, the rate also falls 1/3. What does it mean? It means concentration is directly proportional to rate. Okay, concentration is directly proportional to rate. So this one will be something like a very important knowledge because, okay, I'll just go directly here, okay, because if you look at just now we mentioned about rate, yeah, so rate, okay, rate, and then you have concentration. So out of these three lines, okay, which line that we just studied just now, Lavi?
The
What color?
didn't we study the red and blue?
Rate, concentration, yeah. So I'll just go back again. It's rate and concentration. So you see, rate, concentration. So which one we studied? So rate divided by concentration. So which one is it? Okay, let's actually focus here. Rate and concentration. So which one we just studied? This one, the blue line. Okay, the blue line. Now, some other reactions, they will not follow the same trend. Okay, they will follow different trend. Okay, if you have a straight line, they are called first order reaction. Okay, first order reaction. Why? Because they depend on the concentration. It means it's directly proportional to the concentration of that reactant. It become double, rate also become double. It become triple, the rate also become triple. Okay, so this one is going to be first order. Now, there will be some reactions, okay, will not depend at all to the concentration at all. Okay, they will not depend at the concentration. It means whatever changes to the concentration, it's not going to be affecting the rate. That reaction is going to be called as zero order. The graph is going to be a straight line. Not straight line, it's a constant. It's a constant. And we have also something like a quadratic line. Quadratic means x to the power of what, Lavi? Quadratic.
X to the power of 3.
Ayo. Who's teaching you maths, Lavi? Quadratic graph is x to the power of 2. Cubic is going to be x to the power of 3. Okay, quadratic graph. Yeah. So x to the power of 2. Yeah. So here is going to be, this is going to be to the power of 2. If you have to the power of 2, that's why, okay, it's this graph is going to be known as second order, because to the power of 2. It's like something like a quadratic graph. Okay, so I want you to remember this. Okay, we have 3 types of order: zero order, first order, and second order. Zero order means it's only affected by, okay, the reactant is to the power of 0. Anything to the power of 0 is 1. So it's only affected by the K, which is a constant line. If it is first order, okay, then it's going to be a straight line. Okay, only depends on the concentration. And if it is going to be to the power of 2, then they follow the second order, which is going to be something like a quadratic graph. So what I want you to understand for today is, okay, I do not know whether you understand the graph, whatever things that I actually mentioned, but I want you to understand this particular graph for today. The graph is going to be, okay, reaction rate, and then this one is going to be the concentration. Can you remember this? Reaction rate and concentration. Okay, and reaction rate and concentration, you have 3 types of graph. Okay, we have zero order. This is going to be zero order. First order is going to be from here to here. This is first order. Second order is a quadratic graph. Okay, zero order is rate equals to K, the reactant is to the power of 0. They do not actually depend on the reactant. First order rate equals to K, then rate reactant to the power of 1. They are directly proportional to reactants concentration. When we become double, it become double. When we become triple, they become triple. Okay. Second order is going to be the rate equals to K to the power of 2. Now, how? If the concentration become double, Victoria, what do you expect for second order? The rate become double, or they will change into something else?
Is it change into something else?
Yeah, because it's going to be to the power of 2. So when it become double, so it will become 2 to the power of 2. They will change into times 4. I hope you understand this. So when it become triple, triple means 3 to the power 2. They will become 9. Okay, so it means they will change accordingly. They are dependent on the concentration, but the way they change is different. Okay, the way they change is different. Zero order, they are not affected. Okay, they are not affected by the concentration. Okay, but first order, when the rate become double, then the reaction rate also become double. When they become triple, then they also become triple. But second order, they will follow like something like quadratic. Okay, when the rate become double, then it's going to be 2 to the power of 2, 4. They become times 4. When they become triple, okay, they are going to be 3 to the power of 2. It means they are going to be times by 9. Okay,